review logarithms and then transition into real-world applications and see if I can get to properties of logs. So what we were talking about initially with the intro to log videos was going from exponential, or logarithmic form, excuse me, to exponential form, but we can go both ways. And bear with me. So if you have something that's log base 2 of 16 is equal to 4, the base of the log is the base of the exponent. So since the base of the log is 2, then I know that the base of the exponent is also 2. This part here sort of goes in this E form, if that helps you at all, where you're starting with the base of the log, you're doing this little exponential, E, so 2 to the 4th power is equal to 16. Pretty basic. Same thing with number 2. The base of the log is the base of the exponent. This is the missing power. So 4 to the 3rd power is equal to 64. Just one more, because I want to really hit this. Base of the log, base of the exponent, power is what you're always finding with logs, and then is equal to 625. Because originally, what you're doing when you're finding logs is you're saying, okay, 5 to what power is giving me 625? And you're solving, and 4. So that's where it's coming from. Whenever you're going from exponential form to logarithmic form, it's the same idea. You're going to put your log. You have to put a base unless your base is 10. Then you don't really need that 10 there. It's up to you. Base of the exponent is the base of the log. It's smaller, so you can see it better in type probably than when I write it, but it's a subscript, so it's sort of like the opposite of an exponent. The final answer over here is what comes first. Because again, what logs are asking is it's saying, okay, 2 to what power is giving us 8? And we know that is 3. Pretty simple. For number 5, we're going to put log. You could put a base of 10. You don't need it there. Because log is equal to log base 10. So the common log, just log, is the same as log base 10. And the reason that's like that is because it's scientific notation. We're not going to get into it as much, but that's why the common log is a base of 10. I'm not going to write it. I'm just going to say log of 100 is equal to 2. Makes sense, because 10 squared is 100. Do number 6. I'll do all of these, again, just for practice. Log. Since the base of the exponent is no longer 10, we have to write it. Log base 3 of 243 is equal to the exponent. So again, hopefully pretty basic, and we'll do the last two, just so that way I can talk about these different things here. Number 7, base of log, base of exponent. Here's your power, and we know, hopefully, that that's equal to 1. You should know that any value other than 0, anything to the 0 power is equal to 1. Anything to the 0 power is 1. Anything to the 0 power is 1. Anything to the 0 power is 1. And number 8, base of log, base of exponent, power, and it's equal to itself. Guess what? These are the rules that are down here. Log of a base, 1, is always equal to 0 because any base to the 0 power is equal to 1. Log of base b of b is equal to 1 because guess what? B to the first power is equal to itself. That's why it's like that, and hopefully that makes sense. And then it's going through here, and it's basically telling us that exponents that have the same base as the logs undo one another. So for example, here 10 and log, the common log, cross out because we know, again, the common log has a base of 10. So the answer here would just be 8. Sometimes you have to do a little bit more work. Here, we know that 9 can be written as 3 squared. Do you agree? And then that x is going to fly with it. So in reality, instead of 9x, it's 3 to the 2x. Well, guess what? The 3 and the log 3 cancel, so the answer is just 2x. Same thing here. 125 is 5 cubed. That x is just going to follow and be multiplied with it. So the log and the 5 cancel, and we're just left with 3x. This comes at a different point in Odyssey where way later, so I'm going to ignore that for now. Honestly, you can check my notes. For graphing logs, they look a lot different than exponential functions. They rise, just as a rough sketch, super rapidly, and then they really start to slow. This one actually should cross here and here. It's a really rough sketch. Anyways, they really start to slow. Their asymptote is going to be vertical. It's typically, usually x is equal to 0, unless inside you have a value for h. Then that would give you your asymptote. And there's restrictions on the domain. Honestly, I would use Desmos to graph logs because we were going to use the graphing calculators anyways. It can be complicated. Graphing logs, it's just a pain in the butt. So using logs in real life, probably, well, I'll at least set it up because I don't have my calculator in hand, but I'll at least set them up so that way you can do them and let me know the answers that you get. So it's talking about depositing $2,000 in an account that pays this interest compounded quarterly. Look back, we had this formula where it was A is equal to principal, if my pen works, and then it was 1 plus the rate divided by the number of times it was compounded a year times the rate, or excuse me, times that n times c. So, I'm going to zoom in so that way you can actually read my handwriting. We know that it's becoming $2,400. That's what we were solving for before, but now we know that. We deposit $2,000 into the account. 1 plus, hopefully no 2%, is 0.02 or 0.02 over compounded quarterly, 4 quarters. And then 4, because it's compounded quarterly, times time. And we're asked to solve for time. You could guess and check. That's what a lot of people do, is they try to guess and check. That's fine. Or you can solve for t. For example, you can divide by 2,000 on both sides, which should give you, and again, you can always check this in the calculator. I'm just trying to do it fast. 1.2. I took 2,400 divided by 2,000. Here, 0.02 divided by 4 is 0.005. So it'll be 1.005 to the 4t. You're going to almost always get decimals for time. To get rid of this, you have to take the log of 1.005 on both sides. That cancels. I'm going to write it below because I'm probably not going to be able to do that one, but you can check my notes for the other problems. 4t is equal to, and you would literally type this into a calculator. Log of 1.005 of 2. You would plug that in a calculator, and to get t by itself, you would divide that decimal by 4. Answer. So this is where I'm going to stop the video, and then I'll do another separate video on the properties of logs.